Go ahead. All right. Well, this is our project on the automatic light control. As you can see, we have an op amp right here, and into this op amp we're running this as a comparator, and we have a voltage divider on the non-inverting input, and that voltage divider is going to deliver about 5 volts to the non-inverting input, or to the inverting input, sorry. And then on the top side, into the non-inverting input, we have a voltage divider that when the photoresistor is in ambient light, it's going to have about 1.25 ohms, which will deliver less than 5 volts. And when it's in darkness, it'll have about 6.8 ohms, which will deliver more than 5 volts. So then it'll go between our negative voltage, which we have at 0 volts, and our positive voltage, we have at 12 volts, just because of the nature of what we're trying to drive here, which is a 12 volt LED array. So when the voltage is lower than 5 volts on this side, so in regular light, it's gonna be driving on the non-inverting side, which is gonna give us a 0 output. And so this is connected to the transistor over here, which is 0. The difference in the potential is gonna basically not gonna let the LED turn on, because there's not gonna be anything flowing through there. And when it's greater than 5 volts, it's gonna deliver the 12 volts from here. And this is gonna run in saturation because it's a comparator op amp instead of a regular op amp, so it's not gonna work in the linear fashion. And so we're gonna deliver 12 volts to the base of the transistor, which will create a current here, and which will drive 12 volts up to here in this circuit, which will be lighting our LED. Oh, and the 12 k ohm resistor is going to regulate or sort of temper down the current flowing through the emitter base. Okay, and then so this is going to be our project right here. The photoresistor is this little guy on top. You can barely see him, but there he is. On the side of our cup, we have the LED outputs, which is going to be this spot right here. This spot that's connected to the collector right here is going to be this positive. The negative side of our LED is going to be hooked up to the negative output right here. For the sake of this project, since we are only going to be running 0 volts and 12 volts, which is the same voltage running across here, we just decided to connect them together. So the 12 volts, this 12 volt, this 12 volt, and this 12 volt are all going to be coming into this guy, this peg right here. And then this 0 volt, that ground, and that ground are all going to be tied into this ground right here. And so that's how that's going to run. So you just put the power wires on the 12 volt positive and the 0 volts right here, and then you'll hook up the positive and negative side of the LED array to this. And I guess that's the wiring inside our cup. I don't know if you can see that very well. We've got the op amp down here at the bottom, got the transistor right here, which is connected in. Oh, and for this purpose, I just ended up tying those two posts together. It's going to be the same thing inside the circuit. Mostly, it makes it so you don't have to hook up the LED array's negative side to negative power supply, because of the way we're working it. And I think that's it for right now. It's going? Okay. Now that it's hooked up through the thing, it works now. Current draw goes from on the meter here. When it's off, it doesn't draw. Now it draws 23 milliamps, which is what it's supposed to draw. It's supposed to draw about 25 and draws 23. Yeah, that should be about it. One thing we did have to do on here as a small edit, we took that 12K resistor out because when we were designing this, we were just running this through an LED array that did not have resistors in it to limit the current. So once so it wasn't working, but then once we removed that, then because this was drawing up all the current or drawing up all the voltage, now once we removed that, then it was able to cycle through and work. And that should be about it.